Here we're going to look at the formation reactions to make all these compounds on the right. So first we're going to remember that formation, the word itself means it's forming a compound. Formation, okay? So it's formation of a compound, and these in red here are the compounds that we're forming, okay? So the notation for chemical reactions is you have to draw this arrow here, and you have to have a plus for any chemicals that are creating it, okay? And remember, if it's a formation, that you have to have multiple things forming one thing. That's what the word formation is, okay? So in the top case here, the formation is talking about this potassium, the K2, and oxide. So oxygen, how does oxygen normally come? Oopsies. Oxygen normally comes O2, and potassium normally comes how? K. And remember your states. These states are just from the periodic table, so you should know these. And now you can't forget what we were talking about in the balancing reaction video or in class. You need to now balance the equation. So I'm going to get rid of this red box. We balance the equation here. We've got oxygen, so we need to balance that out. So there's going to be 2 here. Now there's 4 potassiums, we need to have 4 here, and that would be our equation. Okay, easy peasy, lemon squeezy. Okay, let's look at this next one. So we're trying to figure out which reactants form that compound. And we can look at the other way around later, but just for now, let's look at this. We have Cl, and we have P. Okay, so P is solid, Cl is gas, and let's look at it should be Cl2, right, because it's a diatomic. So how many Cl2s do we need? Well, since 5 is an odd number, we're going to need 10 here, and we're going to need 2 here. Sorry, 5 here. So, oops, 5 Cl's here, and 2 there, okay? And so if we've got 2 there, we need to have 2 phosphorus to make up for it. Okay, next one, copper sulfide. So we need to make sure we have copper, solid, and we've got sulfide, gas, I believe it comes. The state I could be wrong, but if I am, that's okay. That's not the important part. Okay, so Cu, that's copper. How many of that do we have on the right? 1. Sulfur, we've got 1, done. Okay, we don't even need to do any balancing. How nice. Magnesium oxide is the next one. Magnesium is Mg, solid, and oxide, gas. But it's dioxide. Oh, actually, the last one here, made a mistake. Sulfur has 8. Okay, if it has 8, then we have to go back here. This has 8, which means this has 8. So, okay, so it would need a little bit of balancing. You have to remember, so that's even a trick that I sometimes forget. You have to remember these diatomic elements and deal with them as such, or polyatomic in the case of sulfur. Okay, the oxygen one here, the magnesium oxide, we've got O2 gas, and we've got magnesium solid. Since it's O2, we need to change this one to 2, and magnesium to 2. Alright, I'm just going to spread these apart a little bit. For the iron oxide, we've got Fe, solid, and we've got O2 gas. Okay, it's not balanced yet though, so we need the O2 to balance. How do we do that? Well, we've got 2 on one side and 3 on the other. Can't divide it up, so we need to multiply by 3 here, multiply by 2 there. Now, how many iron do we have on the right side? 4, so we need 4 on the left side. And that's a balanced, beautiful equation, formation equation. One more here. This way around, we've got phosphorus and sulfide. So we need to put phosphorus here. I believe phosphorus is solid. I think sulfide is a gas. Remembering that sulfide is 8 and phosphorus is 4. So if that's true, now it's going to get a little bit more complicated in terms of our coefficients. So let's make the sulfurs balance first, because it looks just slightly more complicated. So 5 times 8 here, 8 times 5 here, and now we've got 16 phosphorus, so we need 4 times 4 is 16 on this side. Golden. Okay, those are kind of the most complicated formation reactions you'll ever see. It doesn't really get any more complicated than that, other than potentially some polyatomic ions. Okay? Formation is just 1 plus 1 equals 2. It's just this simple formula. 1 here, 1 equals 2 together. That's all it is. Okay, let's do it in the other way. So let's see Na plus, or Na, well, let's just not do plus. Na solid plus a Cl gas goes into, and now we're asked to figure out what it goes into. Well, it goes into NaCl. You just put them together. It's that simple. Solid, and you'd have to balance it out. This one balances out really nicely, it's fine. Let's think about another one. Another potential option is calcium plus chloride. Okay, calcium chloride. Chloride is this gas. Oh, remembering, here you go, this is what I often forget this. So this is the part that you need to remember to do. This diatomic molecule, that tricks me up every time. So if there's 2 here, there actually has to be 2 on this side, which means there's 2 on this side. Don't forget that. That's a huge important part. Okay, so this here we've got calcium on the left, this should say solid, and we've got chloride on the one side. So CaCl2. How did I decide that? Well, calcium, if I were to write this out, don't write this in your actual answers, but is +2, and chloride is -1. So I need this last answer to be neutral. So +2 minus 1 times 2 here, and they all balance out to be a neutral solid. Okay, now if I compare back all my numbers, I've got 1 here, 1 here, 1 here, and it'll be balanced already. And that is your simple formation reaction type questions.